So Kyle is my guest tonight on Physics Office Hours. Let's see here. I think I want to do one thing really quick. Put it up there. That way, if anybody comes in, they want to ask a question, there are instructions. And see, good to see you. Welcome, welcome. Okay, so Kyle, let's see. So I have as ABC has found out, I have a command for Kyle. Kyle is a fourth-year PhD student studying astrophysics at UC Irvine, and he is joined UC Irvine, right? It is UC Irvine. Okay, good. That'd be a bad thing to screw up off the bat. But anyways, thank you for coming out and doing this with us. So the way tonight's going to work is we're going to start with a little bit of a couple announcements. I got some stuff going on the next few days and week that I want to keep you guys all up to date with. And then I'm going to have some conversation with Kyle. We're going to talk about what it's like for him. Kyle studies astrophysics, which is a little bit different than I study, because I study particle physics and quantum computing. But as you know, I was studying, as most of you know, I was studying cosmology and particle physics for the first half of my degree. So I love astrophysics and am very excited to talk to Kyle about some of the things that's going, because I actually didn't get to the cosmology part, Kyle. I didn't get that far. I spent the first 2.5 years working on the field theoretic stuff, so I learned about particle physics and whatnot. But then last fall, I had to change topics kind of like suddenly, and I switched to quantum computing. So I didn't get to the cosmology part, and now I'm envious. But Kyle's on mute. Oh, ha ha ha! I had to lower him. Try now, Kyle. Say something.
Testing 1, 2. Can't hear me.
Are we back now?
Hope you can hear me, guys.
There we go. Yes. I had
neutrino.
muted him for the intro screen, and then we're working on it. It's a work in progress. I'm sorry, guys. Anyways, Kyle was saying that he was taking a general relativity and a quantum computing course at the same time, and then dropped the quantum computing course in favor of the general relativity. Is that correct? Or cosmology?
It was cosmology. Cosmology. Yeah.
Excuse me. So that's why I said we went our separate ways. So it's circling around. Anyways, so the I probably won't be doing too many notifications tonight, everybody, but I do thank you for all the follows and whatnot for those who show up today. I appreciate that. And then the subs and everything will probably be on mute, or at least they should, unless they start going off in the back. Oh yeah, that was just a ding. Okay, good. So my sub alerts can be quite intrusive sometimes. So my mods, if you can help me control the queue. If you would like to ask a question, there are instructions up in the corner for asking a question, where it will go to some place where we can get to it. So yeah, so during the conversation, okay, so what I was saying was Kyle is a YouTuber as well as a PhD student. His YouTube is in the !Kyle link, so please go give him a subscribe. He also streams on Twitch. I saw you streaming Smash.
Yes. Especially with Smash Brothers, but like.
Smash. And what else do you stream? Do you stream chess still?
I do stream chess. Haven't done it in a little bit, but I would like to get back to it a little bit more. And then sometimes I use Twitch just to like randomly like do like a study with me sort of thing, where I'll just sort of like try and learn something maybe on like YouTube, or maybe I'll work through like a physics problem, and then people can just like keep me company while I'm working through something.
Awesome. So let's see here. I have to sip this over. So yeah, so make sure you follow him on all of the social media outlets that are available in that command. Let me bring this back. There we go. Alrighty. So so the way that this conversation is going to work is Kyle and I are going to have some conversation back and forth about just different things that we go through in our everyday PhD physics lives, and then after that we'll do a Q&A. The command for asking a question is up top, and then so we have your questions sort of stored for later. Perk, I did grab yours. It's in the queue now. Thank you for that. And then after that, if we have some time left, which I think we will, we'll play a game. We like to play around these parts of Twitch. We like to play a game called arXiv versus snarXiv, and
Oh boy.
and we usually have some some stakes on the line. Now, Kyle,
Oh.
chat made me. I lost. So I've lost every time, so it's
Oh,
not
no.
looking good for us. But I will say this: recently they won, and I gave them the option to change a channel point reward, and it is they picked push-ups. So
Oh,
for a week,
push-ups.
so they made me do 100 push-ups one day.
Oh,
Kid you not, during
okay.
a 3-hour stream, a building stream. So if you guys are new to the channel, on Sundays we build physics demonstrations and whatnot. And we were working on a hand-powered Van de Graaff generator. And I was struggling to get a bunch of bolts loose. So my arms were exhausting. And then they made me do, on that day, 100 push-ups. So
Yeah,
after
cruel.
a week, I disabled it because I was just like, no, I'm done. This is getting out of hand. So if you can beat Kyle and I, the combined forces, I will reactivate the push-ups for another week. Or actually, so I won't. So that that's a nice segue into the announcements. I won't activate it until next week because I'm actually taking the weekend off, as most of you know. Can you up your volume a hair to equalize Kyle's? Yes, I can. So as most of you guys know, or some of you guys know, I have to do some house renovations this weekend. We had kind of something suddenly happen in the bathroom. We got a hole in my tub, so now the renovations are urgent. So I will be out all weekend doing that. So I won't be back until next Wednesday. Did the other garage catch fire? No, my garage has not caught fire. We will be moving back to the garage in the next month or so. I think we will be, but not for the next month or so. It's still too cold. But anyways, all right. So again, this is Kyle. I'm gonna put his information in the chat one more time, and make sure you go follow him at all the socials. Excellent physics content on YouTube, and just fun to be in chat with on Twitch as well. So. Kyle,
Hi.
I have some questions. I'm curious to get to know Kyle because I've been following Kyle for a few weeks now, few months now. Ever since I was introduced to you during the Donson interview. You were on,
Yes. On
and
Andrew's
then
channel. Yep.
I was curious. So then I hopped in your Twitch channel and we chatted for a while and I found it to be very enjoyable. And then your YouTube channel is very enjoyable. Lots of good content there. Again. A little envious that you get to look at the stars more than I do, so I'm just curious to see how that looks sometimes. But so tell me about you. Where are you originally from, Kyle?
I'm from San Francisco, California, so Bay Area. Born and raised in San Francisco. Yep.
Cool. What kind of education did you have growing up there? Did you go to like a public school, private school?
I'm kind of unique. I went to a private school for like all of my elementary and middle school and high school, but then I went to a public university. So I went to like a kindergarten through 8th grade private school, so 9 years, really long time. And then high school was also a private school in San Francisco.
Yeah, I actually share that with you. I went to a private school from 4th grade. I transferred from public to private when I was in 4th grade and did that through high school, and then went to public university after that as well. How do you feel like that measured up against like your public school colleagues, especially when you got to the university?
Oh, I mean, I think it was a really big advantage in that regard because I think, like looking back now on especially my high school education, like the teachers were really good. The class sizes were very small, and there was a lot of time to get to know your teachers better. There was it felt like everyone knew each other's names. It wasn't like I was just another student in their class. It's like they really knew me, and the teachers were definitely top quality. And I think that when I got to university, I could definitely see that I felt very well prepared to take on college level material based on my high school experiences.
Now, did you have my experience was very similar in the fact that I was taught from brilliant faculty at my private school. However, I actually ended up having a significant problem getting my stuff to transfer. Did you find that yours was along the same lines where I'll give you an example. Like I took Calculus 1 in high school. I took, the just general Calculus 1. And I was taught by someone who was retired and had taught at university level at Purdue for a
Oh
while.
wow.
And then he retired and was just teaching at this local private high school. And it was a lot of fun. And the so I felt like I learned a ton from him, and I was very well prepared. When I went to I went to a community college afterwards, and they wouldn't take it. And they actually tried to get me to take Algebra 2. They wouldn't even let me take Calculus 1
Wow.
in college. Did you have something similar to that, or was everything a little bit more streamlined?
It was definitely more streamlined for me in my experience. Like I took like AP Calculus in high school. I got a 4 on the exam, and then that transferred into being able to test out of Calculus 1. And it was actually interesting because, again, this sort of goes back to how I could see the private school education giving me an edge. I think I was like one of the only people on my floor who was in my dorm that year, my freshman year in college, who was actually in Calc 2. It seemed like everyone was like in like Algebra 2 or or Calc 1 because they didn't have access to, a high quality calculus teacher in high school.
Cool. Well, that's good. I think it was more, I think it was a little bit more localized for me in this area. But it's awesome. I know that there's like a lot of private schools in New York City where like you can get a huge edge. And I'm
Right.
from upstate New York, so like it's a little bit different when you're from the sticks. They don't take private schools seriously. But yeah, so where did you attend undergrad?
So I went to the University of California, Merced. It's the newest University of California. It turns 16 years old this year, so it's going to be able to drive very soon. And
Get that permit.
yeah, I know, right? Get that learner's permit. So yeah, I went there from 2013 to 2017, and it took a while for me to decide on like what my major was going to be in the end, but I eventually settled on physics. So all
Yeah,
was all was L in the end.
I watched your recent Q&A on YouTube, which you should absolutely watch. Watch it. It's really good. Firstly, you should move to the East Coast, by the way. Way better over here.
Okay.
And secondly, the other thing, what were we just talking about? Oh yeah, why you chose physics. I liked that story. Do you want to tell that story? Why you chose physics over chemistry? You were doing the chemistry physics thing, right? Or you were kind of
So
like one foot in each door?
Well, so yeah, that was more of in grad school actually, because I was in a sort of like a chemical slash
really?
physics program in grad school. Yeah, but in undergrad, the problem was I started in mechanical engineering because I really liked physics in high school, like physics and calculus in high school, and I was like, okay, well, what are careers that use those things? So engineering came to mind, and so I started in mechanical engineering, and then I think within the first semester, like I had a lot of friends in that major, and we went to like engineering club meetings and meeting other engineering majors. And I think I could just see that my interests were not in the same place as the other engineering majors. Like other engineering majors wanted to, build cars, they wanted to fly drones, and which are all very cool things. Don't get me wrong; those are really cool things. But there was maybe less emphasis on like, thinking about like what I was into, like quantum mechanics, black holes, string theory, that sort of stuff. And so for those kinds of interests, you probably should just go right into physics.
One of my proudest moments. Now we're going to talk about TAing soon.
Oh, okay.
I'm curious
Oh,
about
great.
your experience TAing because
Okay.
I've been TAing for 3 years now, right? So I will have some experiences to share for that for sure. But one of the experiences that I say now because it's relevant is during my first year of TAing. It was my first class ever. I was so nervous TAing in front of first year students, right? And or second year students because this was like physics. This was intro physics 2. So electricity and magnetism, and I had a couple students who were really interested in physics, like just wanted to talk to me about because I was studying particle physics and dark matter, cool stuff, right? So they were just
cool
interested in like talking about that. So I had one student particularly. I think their name was Sage. I think, and he was coming up after every class and just wanted to just shoot the breeze with me about physics and stuff. And a year later, I think it was like a year and a half goes by. I walked past quantum mechanics and I saw him sitting in the classroom. He was a mechanical engineer student, And when
Wow.
he was in my class, he was a mechanical engineer. And then I walked past the quantum mechanics room and I saw him sitting in the classroom. And I was like, yes!
Got him.
I
We
was
got
like,
him.
yeah.
Hook, line,
But
and
it was
sinker.
like, it was so exciting to see that because I was all like, welcome. But we have cake.
Exactly.
So that's exciting. Now, what was what types of things did you do growing up that were did you do let's maybe rephrase that. Did you do anything growing up or in undergraduate that were extracurriculars? Like, did you compete? Did you work on projects? Did you publish papers? What did you do outside of just your standard run-of-the-mill classes?
Okay. So I guess I'll talk a little bit before undergrad because I think it's debatable. I may have been a little bit more active with extracurriculars outside of undergrad, but I guess in my middle school and high school years, I was on the basketball team in high school and ended up ended up making it to varsity my junior and senior years. So I wasn't like a D1 athlete or anything, but I played basketball throughout all of high school, baseball as well, mostly in middle school, and then my school was so small, actually, private school problems, that we couldn't actually form a baseball team after my sophomore year. So I only got to play baseball 1 year, which was on my freshman year. But I was on the varsity team. I can always say that. I made varsity as a freshman because it was the only team we had. Um, so yeah, I really like those two sports. My dad's a really big sports nut, so he really got me into that stuff when I was young. So I'm from the Bay Area, so I'm a huge San Francisco Giants fan and a huge Golden State Warriors fan, and I get a lot of flack for being a Warriors fan. But I'm like a person who actually is a true fan. Like I don't just show up when the team is like good. Like I've been watching my team since I was like 8, 9, and when they were terrible. So I feel
They,
righteous in my fandom.
how old is that team? Is that team relatively newer?
No, I mean they've been around since the Warriors have been around since like the 70s
Okay.
in the Bay Area, but I think my earliest time like I can remember going to Warriors games and actively watching them on the TV was around that time.
Did you get like a lot of the trading cards?
Baseball, yes, basketball not so much, but yeah, I have a lot of baseball cards somewhere that I'm just planning on holding on to for like ever until they're worth
Same.
like thousands of dollars and then I can just sell them and be like I'm rich.
I used to do that when I was young. Now I am probably older than you, just because I'm probably older than a lot of people. But I'm 32, so a little bit. I went back took some time off between school and
Sure.
stuff. So I when I was young, like 5 or 6, I remember having a bunch of basketball cards from like the 89 into like 93 or 94, and I
Ooh.
found them the other day and I
Oh
still have them.
wow.
Yeah, so I have like this big binder full of old. And I when I was that age, I used to sit there and look through this little magazine to see how much they were worth, because they had like the listing of how much they
Right,
were
right.
worth, and it was always just like 10 cents, 5 cents, 10 cents, and I was like, ah. And like every once in a while it'd be like $1.25, and I'm like, yes. But no,
Increase.
now I'm just one day I'm just gonna do something with it. I don't know. I'll take it somewhere and give it to someone and see what happens. But cool, very cool. So you're into sports. That's cool. Yeah, I played soccer a lot. Did you play any musical stuff? Were you a
Yes.
musician?
Yeah, I did actually. So I played the piano from like the ages of like 6 until like 13 for like with lessons. So I had like 7 years of lessons growing up
Nice.
and played just classical music and mostly just played for like the school for like school events. And I think in high school I didn't necessarily have to, but I think I wanted to choose either being more of like an athlete versus a musician. So I ended up choosing to be more of an athlete. I was supposed to get a role in the band, but then um, somehow that didn't happen. But I didn't complain, so whatever.
Did you do any drama? Did you do any drama classes?
I didn't do like form. I wasn't like in any plays per se, but like in my high school we had like electives,
Okay.
and we did like for some elective classes I took some semesters would be like acting and improv kind of
Mhm.
stuff.
Cool.
So yeah, I had a lot of fun doing that. But I never was in like a full on play at school or anything like that.
Yeah, I've always heard that like improv is like the key to speaking publicly successfully. Like or public speaking, successfully is improv. Like that's like all like the. Have you ever heard of the Alan Alda Science Center for Communication? At
I have heard
Stony
of it.
Brook. Yeah,
I have heard of it, but I have not really looked into it that much.
yeah, they do like a lot of improv if you take like a couple of their courses there. It's just like all improv. So very very cool. Yeah, like I the public speaking and stuff like that. That was a lot of fun. I did some stuff like that. I dabbled in all sorts of stuff between like I was in a plays. I also played a musical instrument for a few years. I played the oboe, believe it or
Oh,
not. The oboe.
wow.
And then I too chose to just abandon it for soccer. I played soccer. I played
Nice.
soccer all throughout high school and college and stuff. I wasn't too into like watching or keeping up with teams. I kept up with the football for a little while, but not too keen into keeping up with it. But either way, so let's get into grad school. This is the the fun part, okay? Firstly, what was it like applying to graduate school? How did you what did you take the GRE, the physics GRE? How do you feel you did with those?
Okay,
You first, and
so
then I'll say mine.
sure, yeah. Oh boy. So I would say, and I'm going to be very candid, I did not have the best graduate application experience. I think I had to take the physics GRE and the regular GRE. And I think there was just a lot of things happening in my life at that point. Like it was like the first semester of senior year, taking a bunch of really hard classes, trying to do research, working a job, also trying to study for these tests. And I think it was just too much to like do well. Like I didn't do that great on either of the standardized exams. And I'm actually very lucky that I got into any grad program at all, because I think I applied to 7 programs, and admittedly, I think a lot of them were, they say, you need to have a balance of like schools that are like, some that you reach, some that are like, safety. I think most of mine would have been like on anyone's, like any really good applicants would have considered most of my schools a reach school. So I got very lucky that I got in anywhere based on my performance on my standardized tests. But I think I did that because I really did feel confident about my undergraduate career. I mean, I think I was a very good student. I was active in some clubs. I did research twice at 2 different research opportunities. I had letter writers who I knew were going to write me really good letters. So I felt very, very good about my chances. That's why I think I went for, some really, really prestigious universities.
Well, I mean, like UC Irvine's a great school for physics.
Oh yeah, no, of course.
Absolutely.
I'm really happy I'm here. Yeah.
Yeah, that's cool. Yeah, there's as anybody who's done this process before, you're gonna experience a world of rejection. It's like
Yeah.
there's so many ups and so many downs with this path, right? And so I didn't even take the physics GRE. I had originally planned on joining the Air Force and not doing graduate school at all.
Oh wow.
Because I couldn't move, as I'm married with kids and a mortgage and a car payment and things like that. So I couldn't like just uproot everybody just to move for graduate school.
Sure.
So instead, I thought, why don't I try my hardest to stay at Binghamton University where I'm at? Because Binghamton's a great school. So I tried, but there was no program I liked. And here's the funny story about the GRE. My quantum mechanics professor in my last year at undergraduate, he told me that we were starting to work together. He gave me 3 criteria. One, I had to get A in his class. I had a C when he told me that. 2, I had to get above an 80 on the general GRE. The math part. Who cares about the rest, right? And then 3, I had to quit my job because I was a chef at the time. I was a cook, and I wouldn't be able to do that. So I told him straight up I couldn't quit because it's grad school and I have a family. Who
Yeah.
I got to
Seriously.
pay the bills, right?
Of course.
So I couldn't quit my job. So he was like, okay, well, we'll see then, right? So then Strike number 2 came when I got a B in his class. But
Uh-oh.
I did try really hard. So he said that would be fine because I had a C when we talked about it, and I got it
Sure.
up a letter grade. So he was like, okay, I'll let that. And then I got like below an 80. I think I got like a 76 or something on the math part of the GRE, the general GRE. And then he's just so then I told him that, and he was actually still willing to work with me because we had been researching for a few weeks, and I think he just was okay with it. But at that point, I was kind of like, look, I just feel like I'm going to be just disappointing you this entire process. So then I was like, I think I'll look elsewhere. And we both agreed that it was probably a bad idea, especially because I had to keep my job. But
Right.
I think that was the main factor. And so then I went to, I was just going to join the Air Force because I was just like, well, I'm going to graduate and have nothing. So I might as well have something. And I thought maybe I'd get lucky and get a physicist job there. But then I had a professor who was working in the particle physics and cosmology who said he would be willing to work with me, and then I jumped ship. I didn't get very far in the process anyway, so it was kind of good. But yeah, that's exciting, and I mean I had the fortunate circumstance of getting accepted pretty much into my university before I even applied because
There you go.
I had a professor who wanted to work with me at my university, so it was a done deal.
Works out. It's great.
But there was still, like I said, there was still quite a bit of rejection along the way, and quite
Sure.
a bit of getting my scores back and just being like, well, this is not going to work. But so, we have our different, our different routines, our different things we do during the day. You are much more computational than I am, I presume. You're very computational, I imagine.
Yeah, fairly. I do a lot of work on all my work is on the computer and just on Python and Jupyter notebooks and coding all day and running models and analyzing them. So yeah, I'd say it's fairly computational. About to get more so even.
So what's it like? What's your day like when you wake up in the morning? What's the very first thing? The first physics related thing that you do in the morning?
Boy, is this a morning that's in the pandemic or not in the pandemic?
Ooh, good question. Let's do not in the pandemic, and then we'll revisit that question later.
Okay, so if it's not in the pandemic, I would be going to my office, and then once I'm into my office, probably the first thing that I'll do is just check to see if I'm usually running something, so to see if it's done first off. If the thing I was running the day before is done, I usually have to keep things running on for days, so seeing if it's done, and then I usually have a list of things that need to be done that's just never gets shorter. It's like you do one thing, you add two more things onto the list, so it's just infinitely getting longer. But I look at the list and think, okay, what is actually doable within today, and that I could hopefully show to my advisor in the next few days. So that's what would be not in the pandemic. Boy, it's kind of weird. I feel like I don't have a really good routine in the pandemic, if I'm going to be perfectly honest. Some days it's like I can sit down and I can just work for hours on end, and then other days it's a real struggle to
Sure.
find the motivation.
Yeah.
And I've also been experiencing computer problems. I don't know if you heard about that.
Oh yeah, definitely.
Yeah.
We chatted a little bit on Twitter about that. How's that going?
Yeah, so I took it. So for those of you who don't know, so I have an Apple iMac that was given to me by my advisor to do my PhD research for, and I got it in 2019. So I guess a little bit less than 2 years ago now, and it worked fine up until like maybe a few months ago, and it started like having these random shutdowns. I didn't know what was going on. It didn't tell me, like there was no error report as to like, well, why did you just shut down on me? And so eventually it came to the point where I couldn't even turn it on to even get to my home screen. So obviously something was wrong. And at the time, all the Apple stores in California were closed because of the pandemic. Sorry. And so yeah, I was kind of in a bit of a pickle because it was like, well, my thankfully I had everything backed up. That was the one saving grace. I had everything backed up. It was on the cloud. So the workaround that was my advisor, who also has a comparably powerful computer, let me make an account on his computer. I brought a lot of the stuff I had done on my computer onto his, and I could run stuff on his computer. That's sort of been a good fix in the meantime, but I've since brought the computer in for repairs on Monday,
Oh, nice.
and they
Oh, good.
said within hopefully 2 weeks it'll be fixed. So
Ooh, okay.
I'm just yeah. I mean, I've waited a couple of months already, so I guess 2 weeks is not
Sure.
too long, but just want it to be done,
So
please.
how has that like impacted your day to day? I mean, you said you were using you had an account on your
Yeah.
advisor's computer, but like, is that something like can you? So do you log into it like remotely and then do work on it?
Yeah, exactly. So I can remotely log on to his computer, and I would say the thing that makes it difficult, and this might be my own fault, but essentially, like since all my files are on the cloud, like they're on Google Drive, like I had like a terabyte and a half worth of data
Ooh.
on my old computer, and
Wow.
so having that stuff trying to load on, like first I have to get it onto like I'll tell you like what happened the other day. Like this is like the perfect like what do you call it, caricature of my day, because essentially it was like I know what I wanted to do, like I knew exactly there was something I wanted to do on his computer that I've done so many times on my computer, but the files I need to do it are somewhere on that Google Drive, and they're not.
Oh
I'm not saying
no.
that they're not organized, but like when I run my code saves a lot of files,
Sure.
and I usually write them in a way that says like, okay, what's the date? What was the model run? What were the specifics of this thing? So it does kind of tell me, which ones I'm looking for.
Sure.
Um, but so there's like these small files that I'm trying to find within a terabyte worth of data, and then I have to extract them off of his computer, off the cloud onto like his computer, make a subdirectory so I can like start up a Jupyter notebook there. I have to make sure all the dependencies that were on my computer in Python are now on his computer, and then I can run it. And that's like usually just one part of a small part that I need to do for my research. And so trying to do something major is like, I'm not saying impossible, but extremely time consuming and annoying and frustrating. So
So I'll answer a question from, or I'll ask a question from chat right now, since
yeah,
it's super relevant. What kind
sure.
of simulations are you currently running?
Right. So what I do, I have a prop actually that helps me try and describe this and get the other prop here. So essentially, what I'm doing is that specifically my research is on super precision measurement of the masses of supermassive black holes at the centers of galaxies that are not in the Milky Way. So galaxies besides the Milky Way sometimes we'll have these things known as rotating gas disks. So you can think of them as these sort of like thin, like spinning disks. So I have this like fidget spinner here that
Nice.
are that come in all different shapes and sizes and are at different orientations. But essentially, you have a spinning disk of gas that is rotating at the center of some galaxies, and you can use the kinematics of this gas by making what is known as a thin disk model. So essentially, you just make a model of a spinning disk that's projected on the plane of the sky. And based on that model, you try and estimate the mass of the black hole, as in, what's the black hole necessary to generate these kinds of motions we're seeing in the thin disk, and then we compare it to the actual observations of that disk in the sky.
Okay,
So
cool.
so I make models that essentially do that. That's sort of the that's sort of the base level understanding of it. But the actual data that I simulate, it comes in a quite complicated form. I can go into it if the audience wants, but it is quite involved.
Okay, well, we'll save that, and then we'll see
Sure.
if we have time at the end. Haney also says, Haney was the one who asked the question, you're so lucky, Lisa will get launched during your career.
Yes. So Lisa is going to be. Um, when is it going to be launched? I
Do
don't
you,
know if I'm.
do
I
you want to
just
explain what Lisa is first, just in case anybody
right.
doesn't know?
So oh man, I don't want to get the acronym wrong, but it's hold on. Sorry guys, I actually don't remember what the acronym for Lisa is off the top of my head. But it's a going to be in interferometer. So the laser interferometer space antenna, right?
There it is.
So this is kind of interesting because Lisa is going to be. Oh man, this is going to involve me explaining interferometry, but essentially the fact that it's going to be in space is great because then we can increase the we can essentially simulate a larger telescope with it being in space, and there are some telescopes here on Earth, and then because in radio astronomy you can sort of simulate the effect of a giant telescope by having telescopes that are spaced far away from each other, and simulated telescope is essentially has the diameter of the distance of those two telescopes. So the fact that LISA is going to be
Oh,
in
cool.
space is a big thing. LISA, to my knowledge, is going to be used for gravitational waves primarily, which is actually not
Yeah.
what I do primarily. Though I do think having an extra interferometer in space would not hurt at all for the purposes that I do. But I think I've thought about it so much. I thought about LISA so much in terms of the gravitational waves that I actually haven't thought about it in the terms of precision black hole mass measurement. So,
Do you think there could be any type of, now this is like out of my field, so sorry if it's not a good question.
no, it's okay. No, it's
But
okay.
like, do you think that there are measurable black holes, or not black holes, measurable gravitational waves from these disks that could be showing up that you could actually get some sort of data out of? Yeah, just like you have a large object spinning or rotating in space, so obviously there's going to be some sort of gravitational wave associated with it. Is it something that's measurable and you can extrapolate some data out of it?
With LISA, I think so because I think like for LIGO, for example, because LIGO's been looking at these gravitational waves in these sort of black hole binaries. So the thing is that the reason why we're able to detect those is because those gravitational waves from the stellar mass black holes. Because let me just try and explain here. So there are different types of black holes, right? And black holes can come in different masses. And you can have supermassive, which are those that are found in the centers of galaxies, which are typically on the order of 1,000,000 to 1,000,000,000 times the mass of our sun. And then you have these stellar mass black holes, which, like their name suggests, they are black holes on the sort of on the mass scales of stars, heavy stars, like on the orders of tens to up to 100 times the masses of our sun. And those smaller black holes generate when they come together and they sort of collide with each other. They generate, I believe, because I don't do gravitational wave science, so sorry if this is incorrect, but I believe that they have higher frequency gravitational waves that are easier for LIGO to detect. Whereas if you have a sort of massive black hole that's sort of not interacting with anything besides like the gas and the stars around it,
Oh, okay.
it's emitting sort of low frequency gravitational wave radiation, which in principle is there, but it can't be really detected by LIGO because of its frequency. But like I said, with LISA, I just actually saw a talk about this yesterday, so I should probably
Nice.
know it a little bit better. But I remember it said that I think LISA can look at black holes in galaxies that are on the mass scales of about 10 to the 7, 10 to the 8. So that would be around 10 to the 7, 10 to the 8 times the mass of our sun. Sorry, I'm so used to talking about this with advisor. That just makes sense. But yeah, so I think LISA will be able to help us with those black holes and their
Cool.
gravitational radiation.
Nice. So that's exciting. And then along those lines, what about James Webb? Titan Astro asks.
Yes, so James Webb is, oh man, I really hope that thing gets launched successfully because I think
It's been a
everyone,
while.
it's been a while. I mean, for those of you who don't know, it was originally planned to get launched in 2018. And so we're still here in 2021. It hasn't left the ground yet. And the fact that it has to go through, it first has to get out of the Earth's atmosphere, then it has to fly all the way to the second Lagrange point, then it actually successfully deploy. I think astronomers are going to have like a huge, like, I don't know, I don't want to say panic attack because that'd be like a 7-month long panic attack because that would take, that's how long it's going to take just about.
Now, last Wednesday we talked about, on stream, we talked about the three-body problem.
Okay.
The
yeah.
second Lagrange point. That
Yes.
is in reference to a solution to a three-body problem, correct?
Right.
So what is the second Lagrange point?
So right. So the second Lagrange point is it's essentially a point that is it's a point where the gravitational force between the sun and the Earth are perfectly balanced. So it is where so essentially something that's sitting at the second Lagrange point is not going to feel a net gravitational force in either direction. So it can sort of stay there in a sort of stable equilibrium without being pulled away in one direction or the other.
Yeah, the three-body problem is a famous problem where, like, if three objects, especially gravitational, is like this is the usual one. We talked about it in terms of a helium atom with 2 electrons, because that's something that I'm talking about right
Right.
now in research. But but it's also, it's super popular in gravitational problems, and putting something and like Kyle said, putting something. If you start the three-body problem, just have three objects in an orbit with each other, they almost always, there's very few solutions, but almost always they end up in chaos, and one of them gets ejected. So having something, like Kyle said, in the second Lagrange point is a good way to get it so that it doesn't get ejected, and that we can keep it in a nice orbit. Very cool. So okay, so that's exciting. So that's what a day in your life looks like, and that's, a lot of great questions and a lot of good stuff from that. Cool.
Wait, can I actually say one thing?
Yeah,
real quickly?
absolutely.
Sorry, I don't think I actually answered the question in terms of like what James
Oh,
Webb
yeah, of
actually
course.
would do for us. So I'll just briefly go over that. But so essentially, what James Webb could do for us is that when we're looking at these sort of spinning disks in the sky, the thing is, one of the biggest challenges in measuring a black hole mass is having enough angular resolution that's just being able to resolve the orbits of gas clouds that are close enough to the black hole. And if you're not resolving that highly, then you're going to see the motions of objects that are also being affected by just the masses of the stars themselves in that galaxy, not just the black hole. And so oftentimes when we make these models, we don't just take into account the mass of the black hole. We also have to take into account the mass of what we call the extended stellar mass distribution of the galaxy. So that's just the contribution of the mass of the stars to the overall gravitational potential. And we often rely on HST imaging to get those contributions from the stars. We use an HST image from the galaxy to sort of measure how much stellar mass is there. But since James Webb is going to be much more higher resolution than Hubble, they'll give us a much more precise estimate of how much stellar mass is there. And it's also working in the wavelength regime in the electromagnetic spectrum, the infrared, where we're actually going to be able to see through one of the biggest problems in my research is dust. So dust is a big problem, and the IR is good for seeing through dust. So that's what James Webb will help us do with these targets, if it makes it. Fingers crossed.
And then Haney has a follow-up with that. I thought the black hole in the center of the galaxy only affected the hub.
The hub. I'm not so sure what the hub is.
Haney, do you want to elaborate on that? Or if you would like, Haney, let's just pop it into the queue and we'll hit it at the end, okay?
Sure.
So I do want to keep moving along a little bit. Let's talk about TAing. This is something that comes up on your YouTube channel from time to time, so I know it's going to be a thing that we have some words to share about. I've always said that like one of the biggest surprises to me of graduate school is how much I actually like to teach. Hate grading.
Yeah.
Absolutely hate it, but love to teach. So my first question is, what was that first semester like as a TA, as like having a class of students? Now, was it a laboratory, or was it a lecture, or like a discussion style, or lecture style even?
It was a discussion-based lecture style. Yeah.
Okay. So what was that first semester like for you personally?
Well, I mean, as a TA, I think it was overall rewarding. It was a introductory Newtonian physics class, like the very first class a lot of these people would see in college. So it was stuff that, fairly simple stuff with respect to like, the level that as grad students as we are, it's like the, stage one of physics. So the material wasn't that hard, but I think what was fun was being able to, interact with the students. Like my job was very like, my professor that I was teaching for was very relaxed, and he said, all I want you to do is answer questions that they have about their homework. That's all you have to do in their class. And if they don't have any questions, then just go over how you would do some problems. So very, very low key. And so we also all my sections were started in the morning. So I had like a 8 a.m. session, and then I would have to go until like noon. So it was just like back to back to back sessions, kind of brutal. But it was kind of interesting because like the first discussion section would be like where I would make the most mistakes, where I'd sort of have to like first learn how to like explain certain things. But then by the end, it was smooth sailing. Like by the time I got to the third or fourth one, it was like I already knew what everyone was going to ask, and like I had already answered the same question like 3 times. So yeah, so I would say it was rewarding because I think the students were receptive to the way that I was showing them how to do things. I tried to, I tried to emphasize having good habits when you're doing problem solving. Drawing pictures, labeling stuff, writing down units,
Yeah.
don't plugging in numbers till the very end, that sort of thing, solving things algebraically. Just really try to emphasize that and just say, hey, look, the more you do this, it's going to be easier for me to grade, which and you'll be much easier for you to get more points and easier for me to grade, and then we're both happy. And I think everyone sort of saw the win-win there. So
Awesome.
we're
Yeah,
receptive to that.
it's a challenge for sure of getting them to write something that's going to make it easy to grade. Because I'm in the same boat. I have to write quizzes and then grade quizzes, and it's the same thing. It's always just like try to get so far without putting in the 5 decimal answer that you got from calculating something through like 4 steps of like your chicken scratch because you're writing in a 25 level font and like it's impossible. So, but now how does it change going online? Because you're still TAing, I assume, right? Or are you just researching now?
So so going online, I've had to TA once in the pandemic. So I did TA. So we're on the quarter system. So I actually TA'd not this quarter, but last quarter, and I will have to TA next quarter. I don't know what it's going to be yet. But so the experience I had TAing in the pandemic was interesting because it was a lab course this time, but it was a astronomy lab course. So, so it was interesting in the sense that we had to get the students to connect to sort of computers on campus because for in astronomy research, this language called IDL is like this old-fashioned language that a lot of astronomers grew up using, and it's still the language that we use to teach our students at UCI, even though the people who made that course even admit now it's probably time to move to Python. So that was interesting because I actually don't program in IDL, so I had to learn how to sort of, roughly use IDL because I was going to teach students how to like use it themselves. So that was an interesting experience. I would say that also, I don't know. Personally, I didn't really like TAing in the pandemic just because I think everyone sort of, sort of feels this dark cloud, and a lot of students didn't want to go to office hours, and
Yeah.
I just spend like 2 hours just waiting for people to show up, and then
Yep.
they wouldn't show up, and so yeah, that's sort of how I feel about the pandemic TA situation.
Yeah, it's I have so when the pandemic started and I was TAing, like that's when I started streaming because there was like I felt like there was a need, like especially in my class, like there was a huge outcry and on Reddit as well about like people just not having anywhere to go to ask questions. Like their professors were overwhelmed, so they were not responding. Especially like my students had the situation where the professors were overwhelmed. They were not responding to emails anymore. They weren't able to get help. The other TAs were kind of like trying to figure out their own stuff and like whether or not they were like we have a lot of international students, so they were trying to figure out whether or not they were gonna have to go home, things like
Oh,
that.
right.
It was kind of like a
Oh,
big
boy.
mess, right? And so that's why I started streaming because I went and just grabbed my phone and a tripod and set up on my blackboard at my garage and was like, I'm going to teach on a blackboard and I'm going to do it right here. And
Nice.
that's what I did, and it worked. I think it worked well, and I've had good result with that. TAing online since then, because for me, the strength though is to be like at a board with prepared notes, going over everything, like at the same way I would do in class, because the student can see me up and like moving
Yeah.
and like engaging, and I would force them to engage, or else I would sit there and tap on the chalkboard until someone answered. It was like it felt more like a discussion, and
Right.
that was my experience as well. But an astronomy lab would be pretty cool. I took an astronomy class, and the astronomy lab was one of my favorite parts, where you would do we measure the light spectra from stars and stuff, and from
Right.
planets and things like as they pass in front of the stars, and like the the different molecules that would be in the atmosphere of that planet and stuff. We got to look at some variations of that and stuff. And then like crater impacts was one lab. That was one of my favorite labs, where we had like a big
Nice.
sand box and we were just throwing nonsense into it and making craters. That was always fun.
Yeah, I think. Oh,
Go ahead.
I think one of the downsides, yeah, another one, I forgot to mention this, but one of the downsides about being in the pandemic was that since we, had to do everything online, that part of the laboratory experience of actually being able to take, data, set up a telescope, stay up all night and get stuff, that was just not, there this year. And so we just had to sort of give the students, previous year data and, which, interestingly enough, it's not actually too different from what actually happens in modern day astronomy nowadays. Like a lot of like astronomers who use like space-based telescopes obviously don't go up to space to use the telescope. So, you just, get data handed to you from an observatory that you've requested and you work on the analysis part. But still, that was kind of a downer.
Yeah, I wanted to ask you about that. Not necessarily about that particularly, but about staying up all night. Like one of the things I remember when I woke up one morning, you were awake on Twitch streaming chess, I think, or something, and you were telling me that you were changing your sleep schedule for the week because you had to collect data. That's a lifestyle, isn't it? Like when you have what if you have like things that you have to do and you have to redo your sleep schedule like multiple times in a few weeks? Has that like ever happened? Like how does that impact your normal studies? Because like me particularly, I'm an old man. I go to bed early and I wake up wicked early, and like that's the schedule. And if that schedule gets screwed up, I struggle. So how does that impact like your daily life? Like with one day, like your advisor's like, okay, you need to stay up in like a couple days.
So actually, it's funny. The time you saw me do that, that was actually the first time I had actually tried to actively like sort of get ready
Oh,
for
really?
an
Okay.
observing run. Yes. So I actually, so it's interesting because I've had I don't know if it's the good fortune or bad fortune, but I've had the fortune of my nights when I have to observe are typically isolated events. So it's usually like I only have to do it once every 3 to 4 months, maybe. So it's not like I have to do it like consistently. Like if I was, and it's also sort of a function of the kind of research I do. But um, I will say that people in my group in the past definitely have had experiences where they've had to undergo a lifestyle change because they were going to observe 4 or 5 nights in a row. So you kind of just have to become nocturnal. For me, the last time I did it, I sort of was preparing for the days in advance just because I really didn't have anything else scheduled because I wasn't TAing. This was the start of this quarter, so I wasn't TAing. Um, you know, I could miss some meetings. Like people understand, like, oh, you're going to be up all night. Okay, just you don't have to come. So it was like I could just, adjust my schedule accordingly where I could just work at night and then sleep during the day. And that helped for the actual observing run itself. But that does happen if you do more, especially if you do observations on the ground, like use ground-based observatories on Earth, then there are times where, yeah, you're going to have to get ready for like a week or two of, staying up all night. And that does require a lifestyle change.
Lifestyle change. That's
Yeah.
kind of cool though. And like, so someone in chat says, Justin said, famously Edward Witten wanted to be an astronomer as a child, but thought that meant going into space. So decided against it. So I wanted to talk to you about this. We're running out of time for the conversation. We're going to start questions in about 5 minutes, guys. So if
Sure.
you have questions, !ask and then your question, and it will go into a separate queue. So you can start asking questions. We've had a decent amount in the queue already. So if you have some questions, go ahead and ask them now. And in about 5 minutes, we're going to start making our way through the questions that you have for Kyle. And let's get that little bit of information out about Kyle, just in case anybody would like to know. There it is. So you can follow Kyle at all those various places and ask any astrophysics questions. We have some good ones in chat. So I'm looking forward to that. But I need to know this.
Okay.
So would you go to space? Would you go to space? Is that like you're not Ed Witten? I'm not Ed Witten. I might go to space. What about you?
I think I would actually. I mean,
Okay.
I've thought about it a lot. I mean, against the protests of my family, where they're like, we would just be scared to death if you decide to go into space. But if the opportunity ar- arose. I'm trying to find the right verb for that, but yeah, I mean, I would like to go and see it for myself.
So are
I
you
don't know
going
if,
to actively try to go to space? Like, are you going to, are you actively going to like apply for,
like a NASA astronaut.
yeah,
Like, I think, yeah. I've thought about it. I think I will try at least once. I think I will submit an application just like at least once in my life, but I would probably have to do a couple of things before I would feel confident enough to do that. Like, probably want to get back into really good shape. Maybe be a little bit more advanced in my career.
the
Um,
getting back in shape thing is the thing that I'm like the most
yeah,
concerned about.
because I look at the people who get accepted to be astronauts, and I know a lot of my friends who are trying to be astronauts too, and I think they're great scientists and they're in shape as well, but they don't get in unfortunately. So it's like it's really hard to be an astronaut, but I think I should at least try and just say I
I think
tried.
I'm on the same. I think I'm in the same boat. Maybe he's just
Yeah,
cast my lot and see what happens. Hope for the
yeah.
best.
And then if it happens, it's like, oh man, I feel like if it happens, I'm like, oh my gosh,
Then
I'm
you
actually
gotta
doing
go.
this.
You're
Yeah, no, then
all
it's
in
like,
at that point. It's like as soon as they're like we're considering you for the second stage. It's like, okay, I'm gonna call my mom, tell her I'm an astronaut. That's it. It's that's yeah. So I'm in the same boat. What do you think about society though leaving Earth as a species, as a human species or other species in general? I guess nothing special about us, but.
I think, just based on what we know about, physics and the universe, we eventually will have to do it, right? Because, like, our star, the sun, is not going to live forever, right? It does have an expiration date where it will, no longer be safe for us to be here on Earth. So we'll definitely have to find a way off this planet and go into a different, star system, solar system. Um, I think maybe the question is more pointed about it happening right now.
Yeah,
Like,
sure.
yeah, it's so soon. Um, I think it's, I think it's just, I think I'm more pragmatic about it in the sense that I just see it as a sort of inevitability, really, and of that, like, we're going to develop the technologies to do it. We have to do it. I mean, we have got like a 5 billion year um, due date. So, maybe we're a little bit
Some
early,
time to
but
plan.
yeah, we do have some time to plan, but I don't really have I don't really have a problem with it, or I'm not really like uh, super gung ho about it either. It's just I kind of see it as like, yeah, it kind of has to happen, and we're sort of at the point where we're able to sort of consider these questions. So I think it's it's a fine thing to do. I mean, I feel like
um,
we have to leave eventually.
yeah, yeah. I'm on the same boat. I think that like we have a lot of resources that are interested in it now, and I think that that's good. I wish there was more resources in kind of like. I hope that the focus tends to be like on what resources can we take to space and also help, Earth. And I think that
Right.
that's kind of something that like we are a little bit more polarized in those two things. It's either like help Earth or go to Mars, like one of the two things. And like at some point, can't there be some technology that helps both? To me, I think like nuclear seems to be
Oh,
able to like
yeah.
help both of those situations out, and there'd be a good opportunity to research for those, especially in physics. Anybody in chat interested? Nuclear physics, very important. Going to be very important in the next 50 years or so. So I think that type of stuff would be cool. I'm looking forward to more of a collaboration between getting off the planet and also working on restoring the a healthy habitat for humanity. So very cool. Awesome stuff. We're gonna move to the questions now. It's 8:06. I want to make sure we save time, so if you are just tuning in at the end of this, we're gonna play a game of arXiv versus snarXiv. It'll be Kyle and I teaming up
Oh
versus
boy.
Twitch chat, which is always I lose. I lose often. I lose everything.
I was practicing.
So Kyle was practicing. I've lost Kyle. Hold on, we'll see if we can get him back here. So we're gonna be doing that. It's probably just a Zoom thing, I'm sure.
Oh,
Kyle,
oh, I'm back.
you're
Okay.
back. Welcome back.
I was
So
like,
you were
oh, did my internet go
practicing.
out? Yeah.
You were practicing.
Yeah, I was practicing, and I was getting them like 50-50 the other day.
Okay.
So yeah, I don't know how
With
how
our
good you score on
powers
that.
combined, I'm recruiting you. Please, please help me. I don't want to do push-ups again. Okay, so right now let's do some questions. You guys have some burning questions. There's some goodies in here. I'm excited to ask these questions. So if you do have a question, exclamation mark ask space and then your question. It will go into a queue where I can manage it. I see a couple trolley style questions. So we'll see how that. We'll see if we have time to get to those too. Boring math professor, I'm looking at you. But good to see you, anyways. All right, here we go. So the first one comes from Perk. I forget the full username because they asked it immediately. But they asked, how does an interplanetary communication system, how could it look like? What challenges would it have to overcome? So interplanetary communication system. If we wanted, like obviously right now we're communicating with satellites on, or rovers on Mars. So that's some form of interplanetary communication. Could it be upgraded so that like we could communicate with our, astronauts on Mars reasonably efficiently?
Whoa, this is a really interesting question that I'll be perfectly honest, I haven't thought too much about, but I do know that currently the way that we do this, how to communicate with our satellites that we've sent out into the deep voids of space, is we have satellites in space, orbiting Earth, and I believe the way that this would have to work probably is we'd have to sort of set up some sort of like interplanetary network where we'd have to like feed signals from Earth to like a satellite back to another planet. And I think the difficulties with that would probably reside in the fact that the speed of light is a finite number, right? It's a finite value. And you're going to have relative motion between, like if you're sending a signal, I don't know the exact how long it takes, but it's a couple of minutes to go from, Earth to Mars by the speed of light, right? So in essence, like you would have to probably have a system worked out where you're going to have to know where the planet is going to be in the next couple of minutes, so your signal actively is detected by whatever communications setup you've got on the surface of the planet. And yeah, I mean, I would think like in my mind, I see sort of like some interplanetary ping pong where you just have like the signal keep getting bounced around between like
Sure.
satellites in between the planets onto like the ground-based system of the planet back to another satellite. Um, yeah, I mean that's sort of how I would envision it, but like definitely the fact that speed of light is not an infinite value, it would definitely be a tough problem.
Right, like you hear like popular science communication and things people talk about how we've been you know giving out radio waves since
Yeah,
the 17th or the 19th century or whatever or 20th century or whatever and it's you wonder about how coherent they are, as a
yeah,
communication source somewhere far away, as opposed to just being like, oh yeah, like they're watching I Love Lucy, like that's to me is not happening, they're not, it's not that coherent of a frequent or of a signal to pick up, but so that makes sense though. The ping pong thing kind of makes sense where you can actually like have a coherent message get around. Have you been following the light sail project and whatnot to get to Alpha Centauri?
no, I have not actually.
So there's a project where they have like a microchip style satellite, and they're
Mhm.
gonna open it up into like a light sail, and then hit it with a bunch of laser pulses from Earth, and
Oh, and they're
then
going
accelerate it. Yeah, yeah,
right.
to like I think they said 25% the speed of light or something like that,
Jeez,
and they expect to get to
nice.
Alpha Centauri in a good amount of time. But great question. Another good, very astronomical question comes from
Mhm.
ABC1. Why does everything spin?
Why does everything spin?
Yeah,
Um,
galaxies spin, solar system spin, planets spin.
right. Well, in essence, it has to do with a couple of things. One, it's essentially due to gravity, but also has to deal with like the with energy. So things typically, okay, I'm trying to go. I was reading about this about spiral galaxies as to why spiral galaxies have their shape, and essentially it has to deal with the fact that it's a combination of conservation of energy and angular momentum, where it's preferred that they you know, if those things are conserved and you sort of start off with these things in sort of in the vastness of space, sort of separated in sort of random directions, it's preferable to have them in to have more stable configurations in a spinning configuration, essentially, mostly due to conservation of angular momentum. Um, and that was a really deep question. It's a very simple question, but it's a very deep one. But
Yeah.
it boils down to essentially the conservation of angular momentum in the absence of like external, forces and torques from other
Sure.
objects.
I think it makes sense, and it's as long as it's not a that because there's no answer for particle physics. There's no answer for why everything spins in particle physics. So it's
What
like
is
my
spin?
yeah, exactly. Well, what is this magical thing? So it's yeah, it's cool to see that like there's my astronomy professor always said that like we don't know how things are formed. But whatever it is, whatever's causing everything to spin and the direction of spin that something takes is all about formation. And it's like it's another mystery. So that's cool. So Solarian asks, what are your thoughts about the theory of whole superconductivity?
Uh,
Maybe black hole superconductivity?
I thought it would be okay.
Or is that
My
something different?
I think what they're referring to, and I could be wrong here, but I would assume it would be like electron hole pairs in like materials,
Oh, I see.
and like because that's what I would think in terms of like superconducting materials. But I know almost nothing
Yeah,
about that.
I've been in condensed matter for like a month, so
Yeah, so I don't have any. I don't really have any
I
comment
just
on
learned
that.
that had a name. I learned that had a name. It was like it has a name, and that the name is not important right now. Let's move on.
Yeah.
Good question though, but I'm sorry, Solarian. Maybe if you ask in Discord, if anybody is just joining us now, we have an active Discord with around 250 to 300 people, and we have several, or I should say, lots now of very talented physicists in there who love to answer questions. Also, a lot of science enthusiasts who like to answer questions and who know a lot. So. If you have good questions, pop into my Discord, !Discord in chat for that link to join into that. All right, so great question, Solarian, but unfortunately, I don't think we have the correct answer. But it's okay to say I don't know.
Totally.
Haney asks, what do you think of using LIGO data as another measure of the universe's size? It's a little bit different from what we talked about with LIGO before.
Yeah.
What would be needed out of a gravitational wave observation to measure to know anything about the universe's size? That's a straight cosmology question.
That is a straight cosmology question, and to be honest, I don't know the answer off the top of my head. Again, I don't do gravitational wave astronomy, so I'm not entirely sure how one would use them to probe the scales of the universe, per se. Um, I'm trying to think of a way that you might be able to do it because it involves interferometry, and interferometry is I do radio interferometry with radio waves, and those are one of the more they're a way that we can precisely measure the distances to like distant objects, because this is kind of going off the tangent here, but the way that it's done, if I'm understanding it, is that with high resolution radio interferometry observations, you can precisely measure the separation of objects on the sky to extreme precision, much better than you can in the optical or in other wavelength regimes. And you could usually essentially have those things as a fixed reference point that you can sort of define a frame of reference to where things are moving with respect to. Because one biggest
Okay.
problems in astronomy is like when you measure something moving, like, oh, this thing's moving at 100 kilometers a second, with respect to what, right? Because
Yeah.
we're moving here on Earth like 0.5 kilometers per second. The Earth is moving around the sun. The sun is moving around the center of is on its orbit, and the galaxy itself is moving. And so that's how you would do it for radio observations. I don't really know how you would do it for gravity wave observations of interferometry. But
How convoluted can these calculations get if something is like relativistic?
Oh boy. Very. I mean, if it's relativistic, then you'd have to, start considering, especially if it's, with gravitational waves. It's funny you mentioned this. I actually was just watching a lecture on gravitational radiation. I'm currently in the process of self studying general relativity right now. So just based on the one lecture I was watching on gravitational radiation, the calculations are scary to say the least on the blackboard, and then having to put them on a computer is sounds even scarier. But
Yikes.
yeah.
Cool. Very, very fascinating, though, definitely. So, one of my mods is applying to graduate school for computational general relativity. Is one of his
Ooh, cool.
areas of interest, and I think that
Nice.
that's going to be it. I mean, that's an exciting field. I
Oh
think
yeah.
it's growing right now, like tremendously, because of
Oh yeah.
all the
No.
data they're getting and stuff. And then when Lisa hits, like, oh, it's like going to be work for decades.
Exactly. I actually
Really
said that I predicted it. I think I predicted gravitational wave astronomy as one of the bigger like subjects that are going to go through a boom in the next 10 years.
Awesome. Very exciting. Okay, so Cryogy asks, do we live in the age of equivalences, and are they cop-outs or stepping stones? So, general relativity has a bunch of equivalence principles.
Yeah.
Are these fundamental?
Um.
I mean, they're
Wow.
fundamental to GR. You know
Yeah,
what
they
I
are
mean?
fundamental GM, but like that seems well, it's again a very deep question. Um, that I'm not so sure if I'm qualified to answer this. I just I mean, let me think here for a second. I mean, GR, to my knowledge, right, is a very good description of gravity in strong gravitational cases, and it invokes these equivalence principles to make its predictions. So again, I think it's kind of hard because I'm not like a theoretical astrophysicist at all. Like I don't delve into theory that much and probe some of these deeper questions. But if I had to say something, I would assume that I would say that these probably are very fundamental to the nature that we live in.
Yeah. Well, they are fundamental to general relativity, as in are required along every step of calculation, right? And
Yeah.
there's I guess if they emerge out of something else would wholeheartedly just depend on what spacetime is again. Like there's so many deep questions that I get on the channel that I always just have to end up saying it depends on what spacetime is. Like
Yeah.
we
Exactly.
just don't know. So one of the reasons it's important to do this, to study physics, to go into graduate school and study physics, general relativity, and whatnot, is to find out what spacetime is. Very exciting stuff. All right, so boring math professor asks, what is mass? He's asked this question like 10 times.
What is mass?
Yeah, so what is mass? I'm going to ask you, because we've all taken our shots. Your turn.
It is a measure of the amount of stuff or a measure of the amount of inertia of an object, as in how hard it is to accelerate it due to a force. That's a very scientific standard answer. But
There
that's
you go. I don't know. He has high standards. We've failed. We've tried Higgs explanations and self interactions from gluons and photon and all sorts of stuff. And so I don't know. Boring math professor. I hope that helps. Okay. Moving on. How do we, you and I, maintain confidence when we tutor or teach labs?
oh man. Um, how do you make? It's kind of. I mean, I don't know if I really think about it, but I think one thing I do is I like to prepare a lot in advance whenever I have to teach. Like maybe I would even say almost obsessively sometimes. Like I always just want to see if I can make sure I can cover all my bases and like really know the material that the students are going to learn, make sure I understand it, and I can try and answer everything. So I think definitely preparation is key to being confident in anything that you do. So that's my
Absolutely.
answer.
Yeah, and just doing it. Like my
Win
first
it.
semester, I was a mess. Like I was a mess my first semester. I was terrified before I started. That was rough. But now I've been TAing for like 8 semesters or something like that in 3 years. So it's like it's been Now it's a little easier. Just a little easier.
Sure.
Yeah. And like you said, now you have you've prepped all the every time you've done it, you've prepped, so you have all that stuff from the previous semesters and whatnot. So it gets a lot easier after you jump in. Okay, so here's a good question. Does astrophysics let's try this. Let me rephrase the question. What's the difference between astrophysics and astronomy?
For all intents and purposes in the modern day, they are absolutely equivalent.
Nice.
That's actually a sentence in like a textbook I have on my shelf and like paraphrased, but essentially for modern day purposes, it's identical. Like, I mean, modern day astronomy uses the laws of physics to understand astronomical things. So, I mean, that there should just tell you that they're essentially the same thing. It's a joke. It's also kind of a joke in the astro community. It's like if you want people to like talk and engage with you just like off the street, you say that you're an astronomer, but if you want them to get scared away, you say you're an astrophysicist. So.
Nice. That's funny. Like that. They do have different connotations. Like that's fun. I never even thought about that. That's pretty good.
I actually have a video on my channel kind of going over that.
That's awesome. There's also the whole cosmologist that's in the mix. So maybe take a second to explain the difference between an astrophysicist and... I mean, obviously, so a cosmologist is a subset of astrophysics, but like, what makes a cosmologist a cosmologist?
Sure.
Yeah.
Oh, it's interesting. Actually, I when I took my cosmology class, this was actually one of the first questions we talked about in class, like what is cosmology? And everyone sort of had their own definition, even our own professor. But the way that I think about it, at least, is that like cosmology, when I think about it, is like you're studying the universe on its largest scale. So you're looking at like, orders of like you're thinking about scales that are larger than just galaxies. You're like thinking about like galaxy clusters, thinking about scales that are close to, the observable universe and the expansion rate of the universe, and, concerned with things like the Hubble constant and if that's changed over time and whatnot. Also thinking about the early universe as well. So you're sort of thinking about how the universe evolved from the moment of the Big Bang up until the present day. So I think cosmology, when I think about it, it's like you think the whole universe is your system essentially. Like when you're doing your calculations, you're thinking about essentially the whole universe. How did structure and galaxies and stuff form from that? Whereas if you do like astrophysics, it's like you sort of restrict yourself perhaps to more specific systems. Like for me, like I'm looking at these types of galaxies that have these rotating disks and black holes, which are more localized to galaxy-wide scales. You could also just look at ordinary stars. You could look at planetary systems. You could look at neutron stars. I mean, there's a lot of sort of smaller scale universe stuff that I think astrophysicists spend their time on, whereas cosmologists, it's the big universe itself.
I see. Cool. Great answer. All right, so let's see. Where are we at? We have 8:25. I think we're good for some more questions.
Sure.
Let's do this one next. Since we were just talking about TAing, I think this is a fun one. Are you the TA that you would have wanted when you were an undergraduate?
I feel like it's kind of arrogant to say yes, but I think yes.
Same. No, I'm all
yes.
about that. Yes, like I actively practice that. Like I actively say, like I want to be the person where if I felt like I had to approach my TA and tell them that I had something going on, especially in a pandemic, like there's like last spring, people were like professors were not there was some professors who were not flexible. And like all these crazy things are happening to the students. So like I think and act on that, on that premise that like I would want to be the TA that I would want to have. So
100%.
Yeah, awesome. Great question. Okay, so Justin asks, what are the big picture experimental discoveries for your field you hope to see in your lifetime? So, you can answer that however you want, either like the mass distribution or like the the whole of astrophysics. What do you want to see happen?
I would want to see us getting more powerful telescopes up, both in space and on the ground, and us being able to look further back in time and looking at these like older, ancient like objects like these quasars that are at like redshifts of like 6 or 7, look at them a bit more clearly. Try and understand, like, one of the biggest uh, questions right now in my field in general is like, how do black holes and their galaxies evolve together through time? And the way that we do this is the way we study this. One of the ways is to measure measure the black hole's mass, measure the properties of the host galaxy, because those things are actually connected in a couple of scaling relationships. And I would love to see us getting better resolution telescopes, both in the ground and in space, that can better quantify, better narrow down those error bars on those scaling relationships and help us understand, sort of this chicken and egg scenario, which came first, galaxy or black hole, and how did they evolve over time? That's what I want to know.
Nice, good answer. Very, very cool. Let's see. I'm gonna skip around a little bit. So Ivy Lions asks if there's any cool visualizations from your work that you would like to share. Now, let me double down on that. Okay. Do you have or have plans of making any YouTube content with any like visualizations, maybe how you made them, either simulation or observation, and like what they are, like explanations for those? Do you have any do you have any content, or have any plans for content where this is a thing?
So to answer the first part, currently do not. Partially the reason why is because I've made a point about this in my YouTube videos, but like there's always the danger of getting scooped in research, and like I've been working on these 2 specific galaxies for the longest times, but I haven't actually revealed what they are yet to anyone, just because I'm just like terrified that someone's gonna steal them, even though that's a small probability. But like, I don't know, it's just like an on principle sort of thing. But they do have some nice visualizations that go with them in the paper that I'm gonna hopefully finish in the next month or so. So there will be some stuff. I will say I do plan in the future, once the paper is released and for future papers, to sort of step through the paper and then go through like the different figures I've created and like talk about what they represent, what they mean, just so like if someone wants to read the paper, they actually know what the heck I'm talking about. Because I think everyone can agree the first time you read a scientific paper, it's just kind of like, what is this? Like just a bunch of really hard words and pictures and graphs I don't understand. So I'd like to do that. I'd also like to try and get into making visualizations for like YouTube, for trying to understand the physics that I do, but it's quite complicated, but I know people have done it. I just have to take the time to learn how to code it up myself. So that would be nice.
Very cool. So we're going to be doing a last call for questions. If you guys have any more questions, please get them in. It's 8:30 now. I want to save us some time to play our arXiv versus snarXiv fun. So we're going to do we have 13 questions left. So I'm going to do 13 questions in less than 15 minutes. So are you ready, Kyle?
I'll go fast, yes.
Okay, here we go. So the first question from Haney says, do you like the image of the Event Horizon Telescope? Could you use that data? Is there any data that you could gather from the Event Horizon Telescope?
So I love the picture. It came out on my birthday, so that was great. Nice. It's actually important because the HT tried to measure its black hole mass. My advisor had a previous student who tried to measure its black hole mass several years ago, and then another group tried to measure it a couple of years ago. So it's a great comparison tool for the different methods, though, and it sides with the other group's measurement, but we still are, it's just one case out of hopefully many more cases to come. So that is one way it can be used, but nothing that I'm using directly.
Awesome. Okay, next question. Haney asks again, do any Lagrange points act like gravitational objects themselves?
I don't think so, but I don't know is the true answer.
Okay, we'll take it because
I'm just trying to go fast.
I'm just
trying to go fast.
I don't know how that would work. But I might be able to think about it for a little bit. Okay, so Haney also asked, I thought the black hole. Okay, so this was the explanation to the problem before the hub. I thought the black hole in the center of the galaxy only affected the central bulge.
Yes. Okay, so that's a really good point, and I'll try and answer it quickly. Essentially, the black hole has a radius known as it's not the event horizon, but it's known as the sphere of influence, where that's essentially the radius where the black hole will dominate the kinematics of stuff within that radius. However, observations with telescopes haven't been able to really get down to those scales until recently. And so if they're resolving on scales that are larger than that, you need to still account for the extended stellar mass distribution of the galaxy itself. However, now with ALMA, my advisor's previous student has shown that you can just quantify the mass of the black hole using just the motions of the gas and not the stars, if you can get deep within that black hole sphere of influence. Yes.
Great answer. Okay, next. Boring math professor, here's a good troll question for you. This will be a short one too. It's really cool to have an astronomer here. I have a question in in astronomy. Is it true that Scorpios tend to be more competitive and assertive by nature, especially when Saturn is in retrograde?
I refuse to answer because I don't entertain astrology questions. Next question.
Yeah, we don't entertain boring math professor around here, so. But he does entertain us. All right, so Cry asks, how much of the latest ideas and problems like cosmology crisis and holographic principle come up in your work? So let's talk about some of the big ones. There is the flatness, horizon problems, things like that.
Yeah. So the flatness and the horizon problem really don't affect my research at all. Like nothing that's like sort of fundamental per se really affects my research in that sense. Not directly, I think, off the top of my head. Yeah, those things don't really affect it. Yeah. Like my research is kind of removed from that.
Nice. Okay. NC, non-dairy neutrino, asks, do your computations include strong field GR models? Do you implement something like parametrized post-Newtonian formalisms? I will one-up that by saying, does anyone in your group do that? And how relevant to that, how relevant to your research is collaboration with these computational GR models?
Okay, so this is something I was really interested in. Unfortunately, it's not something that is really necessary for the things that we do as observational astronomers in this area, because the regions that we're probing are typically on the order of about like 100,000 to maybe 10,000 at the smallest Schwarzschild radii. So that is very, very far away from any strong gravitational effects. Even with like the black hole in the center of the Milky Way, which is the one that we can resolve the best, we're on the order of about 1,400, I think, Schwarzschild radii with the closest star, which does actually show some general relativistic effects. I do want to get into computational general relativity and study gravitational waves one day, so I am interested in it, though it doesn't apply directly to what I do right now. Yeah.
Nice. Great. Great answer. Okay. Let's see here. So ABC says, if we had to make a Dyson sphere, what would we use?
It's bad that I don't know I forgot what a Dyson sphere was.
So a Dyson sphere is the object that I'll just give you I'll give you what knowledge I know about it. It's an object in space that collects energy from a star and then electromagnetically transfers that energy to a receiver to be used on Earth.
I have no idea how you'd begin making that. To be perfectly honest.
I don't. So it was devised by Freeman Dyson, I think, or it was using one of his major ideas. Maybe someone in chat would know where the Dyson sphere idea came from. But yeah, it's interesting. Yeah, I don't know what we would use. Okay, here's a good one. What are the correct units of C?
Meters per second?
Nice.
Or I guess people could just say 1.
That's the value. The correct value is just 1.
1 and dimensionless.
And there you go. It's just the dimensionless constant. Well, it doesn't matter.
I refuse, but I don't like it though. I don't understand. I still am mad at all the particle physics people who like decide to throw away units. Like, why do you do that? That's what I don't get it.
We do all sorts of terrible things when it comes to that. I was always so excited. So when I first went to school, we're on a good schedule. So small anecdote. When I first went to school, I was very interested in mathematics. Right. When I came back to school, I wanted to be a physicist. So I I spent the first year just like pounding my head against a wall, thinking about how terrible like all of the formalisms are that physicists, especially particle physicists, use. And I'm like deep into particle physics, and it's all just like, well, where do you get that from? And they were just like, it's fine. It's particle spin. It is what it is. Like, don't worry about it.
Oh,
And then
okay.
it's like, oh, I'm sorry, what? It's
Excuse me?
yeah. So there's C equals 1, H bar equals 1, G equals 1, I mean pi equals
K
1.
equals 1.
Yeah, who cares?
No. Terrible.
If we should get some natural units in chat, guys. Come on, let's get some. I have a natural units emote.
Oh man, that's great.
When I decide to put everything equal to 1. All right, so Physicsy, a longtime viewer, says, do you have a model? Do you have to model dark matter in your black hole simulations? If so, how is that managed? So what role does dark matter play in your measurements of masses?
Almost none. So typically yeah, actually really. So typically the masses of the predicted mass of dark matter in the very central regions of these galaxies are often on the orders of like hundreds of thousands of times less than the stellar distribution than the actual luminous matter in that area. It's not really until you go outside, outside what is known as like the half-light radius of a galaxy, where dark matter starts playing more important contributions. But for all intents and purposes, dark matter is pretty negligible. I will say that in other techniques of black hole mass measurement that involves using stars, yeah, dark matter is very important because the stars can go to orbits that are way outside the outskirts of the galaxy. But for us, when we're very, very close into the black hole, we don't really need to consider dark matter.
Yeah, there's always that. There's that push right now, especially with some UC colleges, where they're really, really interested in simulating dark matter galaxies. So I kind of, dark matter halos.
Dark matter halos.
Excuse me, dark matter halos. And that's, I just kind of assumed that it was something that, like, while the majority of the dark matter exists in the halo, and that's what they're trying to simulate and stuff, that it's still, perpetuated throughout the whole galaxy and was still something you had to worry about. But that's interesting. That's half a light year at least.
No, sorry, it's called a half-light radius. So that's a half-light radius. Yeah, it's just.
That's a lot bigger.
Yeah, it's a radius where the half of the light essentially of the galaxy is contained, and we're probing like way, 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 way closer in than a half-light radius.
Wow.
Some small fraction of it.
Nice. So let's see. So great question, great answer. Interesting stuff too. Learned a lot. First, this is from Zert. Zert's also been a long-time viewer. First, thank you for being here and talking with us. One of the more interesting discussions going on recently in academia is the mental health of graduate students. Everyone knows the trope of the stressed-out coffee embedding no-sleep student. So it looked like it cut off the rest of that question. Zert, was there more to that question? I'd have to go back a ways. Let me see if I can find it really quickly.
Okay.
Shouldn't take me too long. There it is. Okay, so let's see here. Yeah, there it is. Hold up in a lab office all day. Do you think this discussion should be explored further in modern academia? And do you think certain things such as abusive advisors, overworked students, etc., are kind of swept under the rug?
I think that in the past, yes. I think that it was more normal from what I can tell, like just for things to go on. I do think, at least in my school, there have been a lot of efforts towards promoting a more healthy environment between professors and their grad students. And there are certain things in place, like we have a union for TAs here at UCI and in the UC system that, restrict us from having overbearing workloads, though there are still things that fall through the cracks. Like it's not perfect. And there's also attempts to make, like, there is no union for graduate student researchers, where there could be more of a problem in that case, where there's more of an imbalance of power dynamic and, grad students being overworked. But there are movements right now to get also a union for those persons as well. I will say that I think for the most part, most people in my department, I think, are living a fairly decent work-life balance. Though I can think of maybe a few exceptions to that statement, but things are being done. Yeah.
I think that's very true. I see that it's getting a little bit taboo for an advisor to be a little bit abusive. Like to the other faculty kind of are starting to look down on that a little bit, which I think is huge. I think it speaks worlds, especially, and for me, like I'm in a state school, you're in a state school. I think state schools are, the most, I think they're a lot more, obviously they're far more progressive than private schools. So we have our subset of observations, our data points where I just see that. I see that advisors who hear about the stories of other advisors who are abusive just start to they start to cringe. They start to think that that's not what they want to be known for and stuff. And I think that that's making big steps in the right direction. And I think that means a lot for you and I and for our generation of professors. Where we're going to go and perpetuate that throughout the rest of our lives. So I think that's good. Okay, we've got 3 more.
Okay, 3 more. Got this.
And we have 3 minutes. We're doing good. What would you say to Elon Musk if he was here right now?
Make Starlink satellites darker, much more darker, please.
Is that something that they can do?
I know they've been trying to. I know
Okay.
the first generation of them were terribly bright, and then they made some refinements and they made them dimmer, which I think were still kind of bright. So I would say, please make it even more dim, please. Like it's
Okay.
a good idea. Like it's a good idea to have internet across the globe. That's good, but please don't put us out of business.
Yeah, we were gonna get into that, but we ran out of time. But that's a good sum up of what I was curious about. So, excellent. Next question. JS Rock says, how far out do you think we are from living on the moon?
How far out for living on the moon? I would bet within the next, if I was going to be conservative, like if I was going to be safe, I would say maybe 50 years. That's how soon I think it could happen.
So, like, my idea of living on the moon is like a scientist living on Antarctica. Like someone goes there for a certain amount of time and then, and then comes back with data and collection and things like that. So, like, I don't see anybody permanently living on the moon. But,
Sure,
like,
yeah.
do you see... So maybe there's 2 parts to this. We'll have to go quickly. But do you think that there could be... do you think people will permanently live on the moon? And does that change your timescales if it's just like an Antarctica type of base camp?
That's a good point. I mean, if it's for like an Antarctica type like camp, probably within 20 years,
Oh,
I'd say.
wow.
Yeah, I think. I mean, if we could
Nice.
get some sort of habitable, systems up there, like they had like in The Martian, that's what I'm sort of thinking.
Yeah.
But I mean, I don't know why you'd want to live on the moon, but it's the closest thing to us. So, I mean, I don't know. I feel like,
Say you did it.
yeah, I don't know. I feel like people would still go for whatever reason just because it's the closest thing. I don't know. I mean, people are impossible to predict. I have no idea.
Okay, so then the last question from the queue is Perk Inge, who is the person who asked the first question. So here it's appropriate that we're asking. How distant are high school physics with PhD research? So let me maybe rephrase that or refine that a little bit. It's if you take physics in high school, how far away are you from being able to contribute to research?
I wouldn't say you're terribly far. I think you could still contribute in a way, like maybe not with pure physics knowledge, but I think that, for example, I was listening to a podcast where someone was talking about, who's a grad student in physics, was talking about that they were doing research as a high school student, but they were doing more of just like, data analysis, plotting things, not really doing sort of the fundamental thinking of, what's the physics of the situation, but still, contributing in that kind of role. In terms if you want to like, do theoretical physics and, answer some of these deep questions that are unanswered, you're quite a bit of a ways. You're probably a degree, 2 degrees away, maybe from getting, or like 2 degrees worth of content of things you have to learn before, real fundamental contributions can be made. But even small contributions can still be made from a high school student. I've seen it done.
Okay, so that was a great answer. I agree. There's undergraduates doing research. Undergraduates can do research. I mean, like if you are set up with a good advisor, undergraduates can do and contribute research. High school physics students might be a little bit more complicated. You need a lot of that basic knowledge, but undergraduates can definitely. And some people will say no, but Yeah, that I don't agree with that. I just don't agree with that. So I think that's it for our questions. We have a couple good ones in chat still. I would highly suggest you guys, if you have any more questions, even if you're a freshman, yes, Titan, I believe so. I believe even as a freshman, if you get active in research, you can feel free. You can definitely contribute as long as you have an advisor who's willing to push you and you're willing to put the time and the effort to do stuff. But I don't know at what level of contribution that is. You might, you're not going to first author a paper, and that's unlikely. Yeah. But you can still contribute to that. Doesn't. But contributions to research are many things. They're not just being first author or having giant breakthroughs that change the way of physics works. So yes, hop in the Discord if you would like to get some more questions answered. We have many people there who can answer your questions.
I'll join too.
Nice. And then and Kyle will be in Discord as well. So ask questions. We have an astrophysics channel that Kyle is now in charge of. So that will so again, ask your questions there. It will hopefully we'll have time to get those answered. Now.
Yes.
We have roughly 15 minutes. So.
Yep.
It is time to play arXiv versus snarXiv, streamers versus Twitch chat. Okay, so here we go. I'm gonna see how this works. Give me a second to readjust all of my things. So let me do this really quick. Oops. As you guys are taking a look at the queue and notice that it's empty. Let me make this a little bit bigger. Ooh, too big, too big. Go back, go back. Okay, so there's Kyle and I. Excellent. Let's go here. Now, it's going to be a little bit laggy. I can't help that. Slow computer.
Oh, boy. I see it. I see it.
If it's too bad, we'll just kill the cameras. But anyways, it shouldn't stop. Yeah, let's just kill the cameras. It's pretty bad. Let's see. There we go. So Kyle and I are both here, so you'll just have to deal with the cameras being gone. But arXiv versus snarXiv. If you've never played arXiv versus snarXiv, then the way that this works, and plus, if I kill the cameras, they can't click on my nose, which is a thing, Kyle. They all click on my nose, and then I get this giant bubble around my nose. So the arXiv versus snarXiv is there's two options. One of these options is an actual title on arXiv, the archive of all physics papers or physics and math papers and computer science papers and whatnot. So that's the giant archive of those papers. And this other one, snarXiv, generates a random title based off of things it pulls from arXiv. So you have to guess which is the real and which is the imposter. Now, Kyle and I are going to go first. We'll play best of 5, so we're going to play 5 rounds. And we'll see how we do after the 5 rounds. Then you will play 5 rounds, and we'll have a timer set. We'll have to rush a little bit, because I don't want to keep Kyle too much past 9 o'clock, so we'll have to rush a little bit. But you guys will have to vote using click maps. So once it's your turn, I will activate click maps. And if you're at a desktop PC, you can click on the screen, and and what will happen is that will be your poll. Oh, I don't have click maps on here. Hold on, I have to add it really quick. Luckily, I have it all set up. Okay, now it's all there. So what will happen is you will have to click on the screen, and when you click on the screen, that will be the vote of the poll. Sorry, I'm just moving things around a little bit. All right, there we go. So that will be the results of the poll. So we'll play first, and then it will be your turn. So we'll also have a timer set. I'm just going to use my phone. I'm not going to set up the screen timer because that, again, it will probably just crash everything that I own. So let's just do a timer right here. And Kyle and I will have a minute to select an answer, okay? So are you ready, Kyle? So we're going to do, we'll just skip this one. Okay, here we go. So timer starts now, Kyle. We have type 2B on 3 copies of CYM cross C to the M cross S to the N Sudakov laws.
Okay, it's the other one. I'm going with the other one is the real one. The other one must be the real one, please.
So let's do 45 seconds this time because that's a little bit long a minute. But so then the other one's relations among elements of the quark mass matrices. So you're saying the other one. I agree. I don't think the first one has a real thing. I don't think that's a real thing.
I don't think it's a real thing either. I feel like the second one at least is a real thing in my mind. I've heard
Okay,
of it.
so our first round. 1 for 1. Let's go.
Okay, yes, let's
here we
go.
Number 2. So I stop, reset. We'll do 45 seconds starting now. The U-dual of syndrome anomaly mediation minimizes the mu. This is ridiculous. B-sub mu problem versus a numerical study on the dimension of extremely inhomogeneous matter distribution.
Again, the second one sounds more realistic to me. I don't know what a
Yeah, I don't know
U-dual
what a
syndrome anomaly.
It's a syndrome anomaly mediation.
I have no idea, but I've been wrong before.
That's because the left one seems more like a command. Like this minimizes this. I don't think that's a good title.
I think a numerical study. I mean, that sounds more of a title to me.
Yeah.
Numerical study in the dimension of an extreme, and then that sounds reasonable.
All right, time's up. So let's go. 2 for 2, Kyle.
Okay,
let's go. Here we go.
Woo!
Stop. Reset. Let's start. Okay,
Oh,
on the determination of CP violating Majorana phases. That sounds legit. That sounds straight up legit. A solution of unitary in longitudinal models for B-type branes minimizes entanglement of. Okay, I think the left one.
I go with the left. I think it's the left one
It's
too.
the simple one. It makes more sense.
Occam's razor.
CP violating of Majorana phases, though. Let's think about this, though. CP violating is antiparticle violating.
Yeah.
But Majorana's...
Majorana is... Yeah, they're their own antiparticle, right?
Wait, how can they... Uh-oh.
Uh-oh, I'm confusing myself now.
Oh, we're running out of time. I think we should just try it.
Okay, I'm going to go with that. Go with that one.
Oh, good. Yes.
Yes.
Okay, 3 for 3.
Woo!
Here we go.
Okay, here we go.
We're doing good. We're doing good. Type 1 factors and Type 2b on n copies of R to the 7th discovered from something equations. Attractive Lagrangians for non-canonical inflation. Coincidentally, attractive Lagrangian is my nickname in high school.
I wouldn't guess that. I would be unattractive Hamiltonian.
Oh, no.
Okay.
Oh, so we have 15 seconds.
Okay, I go with the second one. I think it's the second one.
Okay, the second one?
That's what I think.
Oh, man. Okay, yeah. I agree. Let's go. Yes! 4 for 4!
Let's go!
I might win this one. Okay,
Let's
so
go.
perturbative conformal field theories versus non-zero electric charge of the neutrino and the solar neutrino problem. Okay, so perturbative conformal field theories.
I don't know what those are.
I'm supposed to be learning what conformal field theories are. And, oh man, I'm trying to think if they're perturbative or not. Wait. Hey, Justin, real quick, Gallardo is Justin's supervisor. The name from the last paper.
Oh,
that's
really?
his supervisor, yeah.
That's kind of funny.
So, I'll explain this. Okay, so Justin, can you help us out here, please? He's on our team. Oh, we're running out of time. What do you think?
I think it's the first one, but like, I don't know. The second one also sounds reasonable. I think, but yeah, I would go with the
we'll
first
go first. Oh, no!
Oh, no! Was this? Okay, so we're 4 out of 5.
Oh, 4 out of 5. Okay, very good. Now,
Chad needs to get a perfect score to beat us.
Let me show you guys how this will work. We are going to give you guys a minute. Once I activate click maps, is click maps showing up on there? No, okay, good. Okay, so once I activate click maps, I will read the problem. You will have a minute to select an answer. So this problem, we're all looking at it right now. So what I'll do is no timer or anything like this. Click maps is live, so if you're at a PC, you can start clicking on the computer. And what will happen if you click on the computer is eventually, after these votes are tallied, so go ahead and start clicking on the screen. It should be live. Oh, there we go. Now we see it. Okay, so now some users are voting. So again, start clicking on the screen for your vote, and eventually you'll see a bubble start to form. So after a certain amount of time, wherever the center of that bubble is, so the center of the bubble is right about here, that's your answer. Okay? After the time is up, that will be your answer. So 4 people are doing it, and we have about 30 clicks. You can click as many times as you want. Okay, and then something else formed down in the corner. I don't know what's going on down here. But, okay, so then what will happen is after the time is up, there we go, now I see some people doing it. After the time is up, I will click on it, and you will get the answer, okay?
It's so cool. It's like a little amoeba.
Yeah, we enjoy our click maps around
I think
here.
they got it right.
And they did get it right. So now what we'll do is I will start the click maps and start a timer. We're going to skip this round. You'll have 5 rounds. If we end in a tie, then we'll have to do a tiebreaker.
No.
If we have time. If we don't, we'll just call it a tie. And I don't know. We'll figure something out later, guys. All right. So ready? Here we go. I'm going to restart click maps. And your time starts now. You have 1 minute to start voting.
Oh. Whoa.
We have representation theory in type 2b far from instaton versus trivial representations versus type 2b orbifolds with 5D branes and their string duals. So where are we looking at? Okay, so we have 5 people voting. 100% is on the right-hand answer. 6 people voting. Time is about halfway over. So, now we have some people who are they're jumping ship.
Oh.
So we have 20-80 split. It's about a 20-80 split. My nose is not on this, so I don't think Tyrion's even playing. But we have 40 seconds have passed. We're still leaning towards the right side. And let's see here. We have less than 10 seconds now. I think the type 2b orbifolds are going to win. And time is up. Here we go. Okay, so they're on to a good start. All right, restarting the timer, restarting click maps, and go ahead. So now we have entropic approaches to the little hierarchy problem versus multi-Hamiltonian structure of, I'm sorry, what? Lotkeys, not Lockeys. Terra quantum something. Okay, so we have 3 people voting. Let's see, what do we got here? You're going to need to vote a lot more often. Oh, yours aren't hard. Ours, we had, listen, your advisor has a difficult name to pronounce. I'm not going to.
Yeah.
There's a lot of vowels all on top of each other. So, all right, who's voting on chat? Come on. All right, so where are we at? We have 6 people, 51 clicks. We are sitting at a 20-50 split with someone just voting on chat. I don't know why. But okay, here we go. 40-60 split with the right-hand answer. You guys have less than 20 seconds. The multi-Hamiltonian structure seems to be winning. Oh, no, it's 50-50. You guys are running out of time.
Oh.
When the time stops, we are
switching.
voting. You're switching. Okay, so now you're going to entropic approaches to the little hierarchy problem. Let's see. So when you're a parent, you have lots of little hierarchy problems. Let's do the left-hand answer. Oh, no! Yes! Okay, let's go. Here we go.
It can be a tie. At best, it can be a tie.
Reset. Looks like I'm not doing push-ups. Okay, the timer is started. You guys have to start voting now. Some little known computations. People don't even try at these titles anymore because that's like it could totally be a real title. So the computer pulled it from a real title. So some little known computations of some general cases of the strong CP problem versus effective theory of color superconductivity. What are we thinking here? We have 4 people voting. 100% are voting off the page. What are you trying to exit the game? Is this what's happening?
Close the browser.
Close the browser so we don't get to finish. Let's see here. So we have 6 people, 51 clicks. It looks like it's a 70-30, where 30 are trying to close the window. 75. Okay, so we're about 80 people are going with the effective theory of color superconductivity. You have about 5 seconds left. 100% now. Everybody's all in. Here we go. All right, time is up. There it is. Okay, you guys. You have to get these next 2 right. It's a tie. Okay, we're restarted and reset and go. Your time starts now. Overview of chiral perturbation theory versus string theory dimensionality reduced on n copies of ADS sub m. Whatever that means. So
what is that?
So Justin happens to be a string theorist student.
Oh, dang.
At Perimeter.
Cheating.
So he might know this. I feel like he actually has read some of these papers and won't won't
He's
share
like-
that knowledge with us.
He's like, oh yeah, actually one of them was like my
I know.
advisor's paper in '97 or something. I was like, some of these weird papers, I'm like, what the heck? When was this written? It was like, oh, 20 years ago. What the heck?
All right, so you guys have about 20 seconds left. We're 70-30 split with 70 on the left-hand side. The left one sounds right. Interesting. We have about less than 10 seconds left. Oh man, you guys have it's almost time. A lot of string theory it is. Let's see here. Time is up. We're going with the left answer. Oh boy, here it is. This is it. If you guys get this, we tie. If you don't, we will have to we win. Kyle and I win. Time starts now. The click maps is open. A hypersurface defect versus QCD anomaly coupling for the A to GG vertex and inclusive decay. Okay, that's not fair. Okay, I feel like this is an easy one. Let's see what happens. Though we have 2 people with 6 clicks. You guys, you have 20 seconds gone. You're gonna have to make up some decisions here quickly. There's a big push on the right-hand side, even though in chat they're saying left. Okay, there's a little bit of flippity-floppity. You guys, you have to get this right if you want to tie. And if we tie, I'll tell you what, if you guys get this right and we tie, I will turn the push-ups back on for a week. I will do it. I am putting, I think it's the left one. I don't think it's the right one. You guys have 10 seconds. I don't know. Running out of time. Definitely right. John Ken says right. If you guys get this right, I am confident that I am right here. Time's up. You said the right one. Here we go. Are you ready? Click map stop. All right, let's close this down. Here we go. For the push-ups for a week, and you guys can make me do 100 plus push-ups again in a single stream. Why?
No.
What?
No.
What is that nonsense? Can we take a look again at that title? QCD anomaly coupling for that's not even proper LaTeX. Like look at what is still in the dollar signs. They put LaTeX in the title.
Oh man.
All right. Oh man. Well, we did technically tie, but I will put the oh, look at ClickMaps is still there. Wait, go away, ClickMaps. Is going to be is it still running? Let me ask you that, guys. No, it must be still running because I must have that white hue around. But it's okay. We're going to be hopping off now anyways. Let me see if I can shut her down really quickly. Well, you know what? We'll just let it run out. It's just a white hue around the outside. So anyways, thank you so much, Kyle. I had an absolute blast. I hope you enjoyed this as well.
Had a great time. It was super, super fun. I was going to suggest maybe as a compromise for your push-up dilemma, maybe just make it a really high channel point spend.
There we
for
go.
them.
I'm happy with that. Right now it's like 2,000, and they were still pumping them out like left. I was like, oh man. Anyways, thank you all for coming. Let's get some hearts and some claps in chat for Kyle. We really appreciate it, Kyle. Thank you so much. It was a pleasure talking with you, and let's do this really quick. Thank you, NC. I was about to do that. There you go. Tyrion's got my socials out there. NC has Kyle's socials out there. Please give us both a follow. I will not be rating anybody, but there are some good people on. I know that Coxsite Prob was on recently, and there's some other good people on, so make sure you go send some love to them. But either way, guys, thank you again. Have a good night. Kyle, any closing words?
I just want to say thank you guys so much. You were an amazing audience. I was so impressed with the level of questions that people were asking and just the engagement overall. And I was just so happy to spend the time with you guys. So feel free to send any more questions you want my way that you weren't able to ask or I wasn't able to answer onto any of my social medias, and I'd be happy to address them.
Awesome. Thank you so much. Take care, everybody. Again, we will take the weekend off. We will be back next Wednesday at our normal time, 1 p.m. Eastern. We have Electricity and Magnetism Part 7, as well as Old Man Reads Old Books. We're going to be doing, talking about Schwarzschild, Carl Schwarzschild. And we have some good stuff on the agenda there as well. So take care, everybody. I will see you then. Later.